Hello everyone, good morning to one and all. In last session, already we discussed about introduction about differentiation. In this session, I given the formulas about differentiation. So here, differentiation means difference. Difference means separation. Differentiation means differentiation. Differentiation means it is a process. Okay, it is a process of finding the derivatives is called differentiation. Here dy by dx means the rate of change of y with respect to x is called derivative. Again d by dx of d by dx of dy by dx. This is nothing but d square y by dx square. Okay, like this finding the derivatives. Okay, it is a process. The process of finding the derivatives is called differentiation. Okay. Here, first principle of differentiation is that is f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Okay, this is called first principle of derivative. Okay, first principle of derivative. Okay, first principle means first order derivative. First order derivative. That means f dash of x. Here y is equal to f of x is there. Okay, differentiation of y is dy by dx. Here f of x differentiation is f dash of x. This f dash of x is nothing but first order derivative. So first order derivative is defined as limit h tends to 0 f of x plus h minus f of x divided by h. This first principle already learnt in first PU. Okay, and some of the formulas already learnt in first PU. Okay, I'll revise those formulas. Okay, that is d by dx of sin x. D by dx of sin x is cos x. That is d by dx of cos x is minus sin x. That is d by dx of tan x is secant square x. So d by dx of secant x is tan x into secant x. Okay, d by dx of cosecant x. D by dx of cosecant x is minus cosecant x into cot x. Okay, d by dx of cot x. D by dx of cot x is minus cosecant square x. Okay, these are the derivatives of some trigonometric functions. Okay, that is d by dx of sin x. That is sin x differentiation is cos x. Cos x differentiation is minus sin x. Tan x differentiation is secant square x. Secant x differentiation is tan x into secant x. Cosecant x differentiation is minus cosecant x into cot x. Cot x differentiation is minus cosecant square x. Okay, that is d by dx of x to the power of n. This is the general formula of x to the power of n. D by dx of x to the power of n is that is n into x to the power of n minus 1. Okay, that is d by dx of 2x. D by dx of 2x. This 2 will take outside. 2 as it is into here power how much is there? 1. That means n value is how much? 1. That is 1 into x to the power of 1 minus 1, that is 2. 1 minus 1 is 0. Anything to the power of 0 is 1. Therefore 2. D by dx of x square. D by dx of x square is that is 2 into x to the power of 2 minus 1. Apply this formula. Okay, so that is 2x. 2 minus 1 is x, that is 2x. Okay, d by dx of constant. Okay, d by dx of constant is 0. Only one constant is, that is 0. 2 into x is there now. That is here 2 is constant, x is variable. You have to take 2 is we have to take 2 is outside, we have to differentiate x, okay. But here this function is different, this function is different, this function is different. This only constant is there. When only only constant is there, that is derivative of constant is 0. So what here constant and function is there, constant you have to take outside, we can differentiate the variable. D by dx of 2x is 2, d by dx of x square is 2x, d by dx of 2 is 0, okay. These are the some formulas about differentiation, okay. And I'll discuss product rule, quotient rule, okay, and the sum of derivatives and difference of derivatives. That is d by dx of u plus v. D by dx of u plus v is u dash plus v dash, okay, u dash plus v dash. Here u dash means du by dx, v dash means dv by dx, okay. That is d by dx of u minus v, that is u dash minus v dash, okay. That is u dash means du by dx minus v dash means dv by dx. That is d by dx of uv. uv means u v dash plus u dash v. This is called product rule. This is called product rule. This product rule is very important, okay. Product rule. So product rule is d by dx of uv equals to u into v dash plus u dash into v, okay. Now come to quotient rule. That is d by dx of u by v, u by v, that is u dash v minus uv dash divided by v square. This is called quotient rule, okay. So this rule also very important for second PU, okay. So product rule and quotient is very important for second PU. That is d by dx of uv is, that is d by dx of uv is also nothing but uv whole dash, uv whole dash. uv whole dash means d by dx of uv, u dash, that is uv dash plus u dash v. d by dx of u by v means that is u dash v minus u v dash divided by v square, okay. So these things you learnt in first PU, okay. This is sum of derivatives, this is difference of derivatives, this is product of derivative, this is quotient of derivative. This is also called product rule, this is also called quotient rule. Next chain rule. Chain rule is here, that is chain rule. Chain rule are composite derivatives of composite functions, okay. Chain rule are composite function. Chain rule. So here what is chain rule? That is, suppose I will take one function, that is y is equal to sine of x plus 3. This is the one function, okay. So here function means, okay, suppose observe the children here, that is this is the one function, but this is one function, I mean, so here bending of curve is, this is the bending of curve, okay. So and again this is x axis, this is y axis, and again this is x0 comma x1, this is y0 comma y1, I mean I have to find this bending, that is f dash of x is equal to limit x, I mean h tends to 0, x naught to x1, divided by y naught to y naught minus y1. This is called differentiability. This is called what? Differentiability. I will discuss differentiability concept in later, but I will discuss now chain rule and composite functions. Okay, chain rule or composite functions. Okay, so this is about differentiability. This differentiability concept I will discuss later in next session. Differentiation is different, differentiability is different. Now I am discussing differentiation. Okay, in later class I will discuss this differentiability concept. Okay, now coming to chain rule. Here chain rule means, that is I differentiate with respect to x. Y differentiation is what? Dy by dx. Observe children, this is I will take, this whole I will take x. What is, I mean this is I will assume this is x or y. Sign differentiation is what? Cos of x plus 3 into d by dx of this function. Okay, d by dx of x plus 3, that is dy by dx is equal to cos of x plus 3, d by dx of x is how much? 1. d by dx of 3 is how much? 0. 1 plus 0 is how much? 1. That is cos of x plus 3. So by using chain rule, here chain rule means first I can differentiate this function, again I differentiate this one. That is called chain rule. I mean I can differentiate chain by chain, link by link, one by one. Okay, that is called chain rule. Okay, so by using chain rule, by using composite functions, in higher classes you will study Jacobians. Okay, so Jacobians are very, very important in higher classes. Okay, without this chain rule, without this composite functions, without this chain rule and without this composite functions concept, we can't study Jacobians. Okay, now come, I will take one more problem. See children, that is y is equal to tan of x square plus 1. Here y is equal to f of x form is there. This one I will take f of x, this one I will take g of x. That is, this one I will take f of x, this one I will take what? G of x. This one is what? Y. Differentiate with respect to x means y differentiation is what? Dy by dx. This one f of x means f dash of x. This one g of x means g dash of x. Okay, differentiate with respect to x. Y differentiation is dy by dx. Tan differentiation is secant square of x square plus 1. That is, here I will differentiate this one also. D by dx of x square plus 1. That is secant square of x square plus 1 into x square differentiation is what? 2x. 1 differentiation is what? 0. Okay, by using chain rule I differentiate this function. Y differentiation is dy by dx. Tan differentiation is secant square x. Secant square of x square plus 1. And again d by dx of x square plus 1. Secant square of x square plus 1, d by dx of x square is 2x. Okay, I will move on. One more problem. This is very simple. Chain rule is very simple. Just you have to differentiate chain by chain. That is one by one. That is called chain rule. Okay. Suppose I assume this is f of x, this is g of x. Okay. I can differentiate first what? F of x. And again I differentiate what? G of x. Okay. Now come to, I will take one more problem. Without this formulas without this differentiation of these functions you can't understand exercise 5.3, 5.4, 5.5, 5.6, 5.7, 5.8 and including MISC problems. Okay, first you have to learn how to differentiate the functions, then automatically you will go for parametric functions, second order derivative, Rolls and mean value theorem, inverse trigonometric functions, larger limit functions, exponential functions, okay, and some other functions. I'll take one more problem. Y is equal to cosecant of x square plus 2x plus 1. Dear children, this is one function, this is one function. First differentiate with respect to x. Y differentiation is dy by dx. First I can differentiate this term and afterwards I can differentiate this term. Cosecant differentiation is minus cosecant into cot of x square plus 2x, this one I can assume x, cosecant x, that is minus cosecant cot, cosecant x into cot x, cosecant x into cot x, okay, that is cosecant of x square plus 2x plus 1, cot of x square plus 2x plus 1 into d by dx of x square plus 2x plus 1, that is minus cosecant into x square plus 2x plus 1 cot of x square plus 2x plus 1 into d by dx of x square is 2x, d by dx of 2x is plus 2. This is the derivative of your function. Okay, so in next class I'll discuss remaining problems of this differentiation. Okay, so please all of you learn first formulas and all of you learn chain rule concept and all of you learn this type of problems. I am concluding the class. Thank you one and all.